Okay, so on this page, example 3 and example 4, this is where we practice how to do calculations involving logs. So we have various different calculations on this page. Okay, so in example 3, each of them, you have the variable x, which is unknown, and we're trying to solve for x. Sometimes the x is located here, and sometimes the x is located in the base. So in each case, it's going to be slightly different. Okay, so the approach we're going to take again is to understand how the log is set up. We rewrite it into exponential form, right? So in exponential form, is the base raised to the exponent is equal to this thing, right? So when we write it out, we have 3 raised to the second power is equal to this thing, which is x, right? So in exponential form, it tells you, it shows exactly how you should calculate x, right? So x is equal to 3 to the second power. And so if you calculate that, 3 to the second power is equal to 9, right? So x is equal to 9. And so by changing it to exponential form, we can immediately calculate what x is. Okay, so let's look at the other examples. Right, so this is the base, this is the exponent, and this is the result. So writing it out, the base raised to the exponent is equal to the result, which is x. And so again, we see that to calculate x, I need to do 8 to the 1/3 power. So let's calculate that. So 8 raised to the 1/3 power. So again, I need to put the 1/3 in parentheses, is equal to 2. So we see that x is equal to 2. So again, when you do 8 to the 1/3 power, you should enter it in like this. Okay, so let's continue to the next one. Right, so this is the base, this is the exponent, and this is the result. So writing it out, base raised to the exponent, so 6 to the minus 3 is equal to x. And so whenever you have a negative exponent, what does that mean? It goes into the denominator, right? So 6 to the 3rd power in the denominator. And then now we just calculate 6 to the 3rd power. So 216. So x is 1 over 216. Okay, so in the next example, now the variable x is in the base, the 5 is the exponent. So when I write it out, it's x to the 5th power is equal to this number, which is 32. So now how do I solve for x? Well, x is now in the base, so I have to cancel the exponent. And if you remember, the rule for canceling exponents is to raise it to the reciprocal power. Okay, so that cancels the exponent. So x is equal to 32 to the 1/5 power. Right, so again, when you enter into the calculator, it should be entered like this. So what is this equal to? So 32 raised to the 1/5 power which is equal to 2. So it was equal to 2. Okay, so next problem. It's the common logarithm. So that means its base is 10. This is the exponent. Right, so 10 to the third power is equal to x. So I just need to calculate 10 to the third power. So that 10 to the third power is equal to 1000. Okay, finally, natural log. That means its base is e. This is the exponent. So e to the second power is equal to this thing, which is x. So what is e to the second power? So this is the natural number e. So raised to the second power, and we get about 7.389. Okay, so again, we can check our answers here.